Welcome to the channel, students. Today we will study about the effect of dielectric on capacitance. Earlier we have already covered about the capacitor plates with air or vacuum in between. Now today we will see what happens when a dielectric slab of dielectric constant K is introduced between the plates of the capacitor. So let's start our understanding of the topic. Consider this parallel plate capacitor already known to you with the plates P and Q. P is with positive charge, Q with negative charge, A is the area of the plates, D is the distance between the plates, all the parameters known to you. So I will denote it with C0, means the capacitance of the capacitor when air is the medium or vacuum is the medium between the plates. Here we are already familiar with this term epsilon naught A upon D. This is the expression for capacitance of a capacitor with air or vacuum in between the plates. Now suppose little change in the situation. We have introduced a dielectric slab in between the plates of the capacitor P and Q. The thickness of the slab is T and the applied electric field as before. Here also we have applied the electric field E0. Here also same electric field E0 is applied. The change is instead of air, now we are having a dielectric slab between the plates of the capacitor. Now what is dielectric? What is polarization? How the slab behaves? All these things we have already covered in the previous episodes. If needed, you can look at those episodes. So moving ahead, there happens the concept of polarization. Polarization means what? Both the faces, both the plates. Here, both the plates receive induced charges. Here they will receive induced charges. Charges will be induced and these induced charges will be, of course, opposite in nature. That means the positive side of the plate P will induce a negative charge on the dielectric and the negative side Q will induce a positive charge on the dielectric slab, faces of the dielectric slab. Now what will happen? Due to this induction or the method I told you, polarization, we have covered these things in the previous episodes. If required, you can refer them back. Both the plates receive induced charges and the induced charges are opposite to each other. Due to this presence of induced charges, there will be an electric field. We call it E-polarization. What is E-polarization? This polarization gives rise to EP, which is electric field due to polarization. And this electric field causes a reduction in the amount of electric field within the dielectric. So what happens to the net electric field? Net electric field is E applied, which is E0, minus E polarization. Why we have subtracted these two vectors? We very well know that the electric field is a vector quantity. Why are we subtracting it? Just because they are in opposite direction as is visible from the diagram. Applied electric field is from P to Q and the polarized electric field which is inside the dielectric is against this direction. So the net electric field is E0 minus EP and of course they are all vectors. So this net electric field will be existing inside the dielectric. So there are two types of regions now. There is a division or segregation or separation of regions. In region T, that is inside the dielectric. This is the thickness, we have written thickness of the dielectric slab. Inside the region T, the electric field will be E net. that is applied minus polarized. And in the region D minus T, what is D minus T? D is the distance between the plates of the capacitor and T is the thickness of the slab. So D minus T means this empty space where the dielectric is not there. So D minus T, here the electric field is the applied electric field only. And what are we up to? We actually want to see the effect on capacitance. So instead of complicating things, we will just say I need capacitance. And what is the formula for capacitance? Capacitance is charge upon voltage. Now I have referred it as C medium. Why? It is C due to air. When the air was in between the plates, this is C medium. When there is some medium, that is the dielectric slab is in between the plates, charge remains the same, only there is change in potential difference. Why? Because V, it is related to the distance between the plates. V is equal to ED. Now we are interested in finding the net value of potential. So how to find V net? V net is equal to, we are going to use this fundamental formula, electric field into the distance between the plates. Now there are two types of electric fields for two distances. First, we have in the region that is D minus T, the electric field is E naught, plus in the region T, the electric field is E net. So we are taking basically E into D. If the distance is this, electric field is this. If the distance is T, the electric field existing is E net. Just, we are already familiar with this thing, that E applied upon E net is equal to K. This is something which you know. So E net can be replaced. I am replacing D minus T. These things remain the same, plus instead of E net I will be writing it as E applied upon K. Now what is K? K is the dielectric constant of the medium. This is E applied upon E medium, which is K, that is familiar to you, you know it for force also. So taking, now these are all mathematical simplifications which you understand. This was the only concept of physics we have used over here. Forthcoming steps will be purely mathematical arrangements. Taking epsilon naught common, I get, not epsilon naught, electric field E applied common. From here I get D minus T, plus here I get T upon K. I've got the value of V. What I want is C, that is capacitance in the medium, which is the ratio of charge to V net. So I'm substituting it there, and V net, little more simplification. This is applied electric field. Applied electric field can be written as sigma upon epsilon naught, and sigma can be written as Q upon A. So E naught can be written as Q upon A epsilon naught. This is applied electric field can be written as sigma by epsilon naught. Sigma is Q by A. So this term remains the same, D minus T plus T upon K. I've got the value of V. I can directly put it in this formula and get the required steps. So what am I going to do? Here I am going to substitute C medium is equal to Q divided by V net. What is V net? It is Q upon A epsilon naught D minus T plus T upon K. Very clearly you can see the next step, C medium becomes, Q gets cancelled, and what am I getting? Epsilon naught A in the numerator and D minus T plus T by K. This is in the denominator. And if I want to tell you that this is the final expression, actually what we need. This is the final expression. Little more rearrangements could always be done in this experiment, but in this expression. But this is what we wanted to get. C medium is epsilon naught A upon d minus t plus t by k. If we want, we can make little more rearrangements in order to establish the relation between C naught, initial capacitance and capacitance with dielectric. For that little rearrangement, C medium can be written as epsilon naught A divided by, if I can take this d as common. Why? Because then only I can express it in terms of initial capacitance. So taking d common, I get 1 minus t upon d plus t upon dk. What is this term? C medium is equal to, what is this term? Epsilon naught A by d is nothing but C naught. C naught divided by 1 minus t by d plus t by dk. If you want, you can further write it as C medium is equal to C naught 1 minus, you can take t by d common from both the terms, t by d, this is 1 minus 1 by k. This is another simplified expression for C medium. This is the relation which correlates C medium to C air. This is the relation, this is something we actually wanted to calculate. This is after little rearrangement we are getting the relation between C medium, means capacitance with dielectric and capacitance in air. So this is a relation. This one important thing will make things more clear to you. If in place of C medium I am putting epsilon naught A by, if suppose I am having the thickness of the slab is equal to D. If this is the situation, what does this mean? It means that we can write it somewhere else also. What does this mean? This means that if the entire space between the plates of the capacitor is filled with dielectric. When I am writing, I will better write it here somewhere at the top so that it's clearly visible to you. So I'll write it somewhere here. If this is an important condition, so I will, if this is the only condition which has been dealt in your NCERT. In NCERT, this is the only condition. Nothing of this sort is mentioned in NCERT. They have only dealt for this single case. They have not dealt with the case when T and D, they are unequal. But we have to do this because its roots are far spread and there are many things which are connected to it and it forms the base. So when T is equal to D, that means when the thickness of the slab is equal to the distance between the plates, इसका मतलब पूरा का पूरा space जो दोनों plates के बीच में है, आपने completely dielectric से fill कर दिया. You have filled the space between the plates of the capacitor with dielectric. Then what am I getting? C medium is equal to, if I am using the expression, then I will get epsilon naught A upon D minus, in place of T, I will put D plus D upon K. In place of T, I am substituting D. So what am I getting? Here I am getting very clearly C medium is equal to K times epsilon naught A by D, which is nothing but K times C naught. That means what? The capacitance becomes K times when the entire space between the plates of the capacitor is filled with the dielectric slab. Capacitance becomes K times. C medium becomes K times C naught when the dielectric slab introduced is having its complete space occupying the plates of the capacitor. So this is the explanation. One thing you need to keep in mind, keep it in your mind, that when some dielectric slab is introduced between the plates of the capacitor, Q remains same. This will help you a lot in doing the questions. conceptual and numericals. Q remains same. V decreases. What is V? Potential. V decreases. Why it decreases? Because we know that when C increases, obviously जब आप dielectric slab डाल रहे हैं कैपेसिटर में, आपका capacitance बढ़ रहा है. When C increases, V has to decrease. So V decreases and E also decreases. क्योंकि V and E are directly proportional to each other. So you need to understand this is something very, very important. Q remains same, potential decreases, E also decreases in this particular situation. So I hope you have got it. You need to refer to some of the previous episodes in order to be clear with the terms I have used here. Thank you. Take care. Goodbye.